Hello everybody, welcome to another video of computational thinking. Okay, in this video we are going to talk about algorithm and core algorithm concepts. Okay, what is algorithm? That is just what we are going to discuss here. So an algorithm is a precise step-by-step method for solving a problem. Okay, see, computers are mindless machines. They are not smart. Okay, they just simply do exactly what they are told. If instructions are followed precisely, an algorithm leads to an automated solution. Okay, so an algorithm must just give the correct answer. Okay, we learn algorithms for doing multiplication at school, for example. Okay, so if a human or a computer follows these rules precisely, they can solve any multiplication problem. So that is just an algorithm. Okay, an example for that, for example, yeah, stage one, input and planning. Okay, so you have just got an input. These are just your inputs, things that you need to do. Then in the stage two, that is processing and assembly. Okay, step one, for example, join base insights. Step two, attach the backrest. Okay, and stage three, that is output and solution. Okay, so just that is how you just simply show the finished assembly. Okay, so we have gotten what? Input, processing, and output model here. Clear? The quality check, or simply five characteristics of an algorithm or a good algorithm. Okay, so the first one is an algorithm has to be unambiguous. Okay, instructions cannot be misunderstood. You have to be very precise, okay, about what you want the computer to do. For example, turn is ambiguous. It can just mean many things. Okay, but turn 90 degrees left is precise. Here computer cannot just make any kind of mistake. Okay, then the second one, that is sequence. Okay, uh, algorithm is an ordered set of instructions, so the specific order matters to the outcome. If you just kind of misplace the instructions, you just put an instruction that has to come later earlier. Okay, so the output will change, so you might receive a wrong output or result. So that sequence is very important. Okay, then it has to be finite. It must have a clear start and a clear end. It cannot run forever. Okay, so any algorithm must have a start and an end. Okay, then the next one, that is effective. It has to just kind of be correct, and it must produce expected outcome every single time with any input or just data. Okay, so only, even if in one scenario only with one output your algorithm gives you a wrong answer, okay, so that algorithm is not correct. So it has to be just effective. Okay, and the last one is efficient. Okay, an algorithm has to be efficient. It must solve the problem using the shortest possible time and the fewest computer resources. Okay, time and memory or just things like that. So these are the five main characteristics of an algorithm that you have to just be very careful and you have to consider while creating algorithms. Then the IPO model, okay, which is just the engine or the very important thing in designing algorithm. Okay, so always we have to identify the input, output, and processing requirements at the very outset of problem solving. Then after that, yeah, you can just think about how to just do them. Okay, so the input process output framework defines algorithm requirements. Okay, so input, that is receiving data. Okay, for example, entering a search term. Processing, calculations and decisions, what things it needs to do. Okay, so that is in the performed by the hardware of computer or by CPU. Okay, example, searching the database and sorting the results, something like that. Okay, and after that, output, sending data to the screen or to just the user. Okay, so that is displaying the search result on the screen. So this is what you have to do for any algorithm. Now we have gotten three languages of logic, okay, or three different ways to represent algorithms. The first one is the written description. Okay, that is natural human language, simple, written in plain English. Okay, so it is simple, but it is prone to ambiguity. Okay, it means many things can be just unclear there. Okay, so that is this kind of written description. Mostly it is just used to communicate between non-technical people. For this we just do not need a lot of technical skill or knowledge. The second one, that is flowcharts. Okay, flowchart is visual diagram using specific shapes. Each shape means something specific. Okay, and it is excellent for showing the logic flow and decision at a glance. So it is easier to understand. Okay, and easier to just kind of faster to understand. Okay, so that is just flowchart. And the next one is pseudocode. Pseudocode is a structured code-like language. Okay, it is not specifically code or just related to any specific language. Okay, so you have to just kind of uh, understand that. And here it uses variables and strict syntax. Okay, not so strict. Okay, but yeah, again, it is more strict than written description. Okay, so it makes it easy to translate directly into high level programming languages. So it is like uh, code. Okay, it is just not exactly that, but before coding it can be just used to design the solution and communicate the solution between team members or things like that. Okay, so there are just three different ways to represent algorithms. Here we've just gotten an example of adding two numbers in written description, flowchart and pseudocode. Okay, as you can see, flowchart has a start and end. Okay, so see the first step in written description. For example, we write enter first number. In pseudocode, inside the in flowchart, inside a parallelogram, we just write that enter first number or input first number. Okay, and in pseudocode, see here, send please enter the first number to display, then after that receive first number from keyboard. You can just write data type of that as well. Okay, for example, receive first number from inside brackets or inside parentheses, you can just write integer keyboard. Okay, then the next step to enter a second number. In flowchart, again inside parallelogram, enter second number. Then in pseudocode, send please enter the second number to display and receive second number from keyboard. Step 3, calculate total by adding first and second number. In flowchart, yeah, inside a rectangle, we just write total is equal to first number plus second number. And in pseudocode, yeah, we just write something like this, set total to first number plus second number. And step 4, output total. For output as will be used just parallelogram, so that is just output total. And in pseudocode, yes, send total to display. Remember one thing, okay, send in, please enter the second number, that is just written inside quotation marks. Okay, so exactly this will be written, but total is not written inside quotation marks. Okay, so it means total is a variable and you have to just display the value of that. Okay, so that is just a very simple example for written description, flowchart and pseudocode. Then visual logics or flowchart standard symbols. Okay, we use ovals for terminals, it means start and end. We use parallelograms for input and output. We use rectangles for process. Okay, what things the computer need to do. We use diamonds for decision. Okay, shows yes or no, true or false, and just simply it is used for the decision. Inside it you will write your condition and the two outputs. Okay, if condition is true or if condition is false. Then we use a rectangle with two lines at both sides for subprograms. Okay, it denotes a predefined subprogram or function. And the arrow is simply used for showing the flow or direction of execution. Okay, so that is shows the logical flow of the program. So they are just some standard shapes used in flowcharts. In pseudocode as well, we can just have some commands. Okay, for example, set counter to 0. It means just, yeah, counter is a variable, put 0 inside that. Okay, assigned a fixed value. Or set sum to score plus 10. So it's simply computes, then after that sends the result to the variable sum. Okay, or for example, input and output. Okay, send have a good day to display. Okay, or receive name from string keyboard. Okay, it has to just be kind of a string, and you have to just kind of be descriptive about variable names. Okay, always use descriptive identifiers, for example first name instead of only x. Okay, that makes your logic easier to understand and easier to trace. Some common pitfalls in flowcharts you can just have. Okay, for example, missing variables. Okay, Identify your IPO requirement. So here we are just missing the input. Okay, where do we have just kind of input and what do we have to input? Wait for water to boil, that is ambiguous. Okay, a computer doesn't know what boiling looks like. So simply you have to be precise. For example, use a decision diamond here. Okay, if is temperature equal to 100 degrees or not? And for example, yeah, we've got an oval, that is just good use of terminal ovals. But simply you have to just ensure every flowchart or every algorithm ends. Okay, infinite loops will just cost you marks in the exam. Okay. Then algorithm success tips: be precise. Again, I'm just saying that, okay, it's very important. That's why we are just kind of emphasizing that a lot. Okay, avoid wait for it to heat. Use wait until temperature is 100 degrees Celsius. Okay. Then finite check: every flowchart must have a start and an end. Okay, and if you have gotten loops, your loop must end. Okay, be careful about the infinite loops. Identify IPO first. Okay, when designing, list the input, process, and output on your scratch paper first to structure your answers correctly. And read the stem. Do not repeat facts already given in the question. If question has just given you something in your answer, do not repeat them again. Simply use them to build your logic. Okay, and be careful about the terminologies. Learn the terminologies. If asked to define, provide the exact technical meaning and purpose. Okay, so purpose is just kind of different from define. So that is just kind of in the paper, you can just use that. Then practice. For example, what is the function of the diamond symbol in a flowchart? See, what is the function of it? Means what it is used for. It simply denotes a decision to be made, presenting two alternative paths: yes, no, or true or false. And define the term variable. So that's definition. Okay, a container used to store data where the value can change during the course of a program. Now it has not asked why it is used. Okay, so you have to be careful about these things in the exam. If you are asked for the purpose and you define it, you will lose mark there, and vice versa. Then yeah, there it's just another practice. Okay, draw a flowchart for an algorithm that greets a user by name. For example, if the user enters the name Fred, the algorithm should output hello Fred. So that is start, receive name in parallelogram. Then we just do not have anything else, just simply send hello. This is the sign of concatenation in algorithms. It means combining two strings. Okay, hello is written inside quotation marks, and name is just not written inside quotation marks. It means it's a variable, and we have to just print the value of that. Okay, so send hello concatenated with name to display, and after that, yeah, end. Okay, so that is just another example. Then write an algorithm expressed in pseudocode that asks the user to enter their height in meters and weight in kilograms and calculate their body mass index, BMI. Okay, and formula for BMI is weight divided by height to the power of 2. Okay, so see, and the IPO breakdown. Okay, here we are just kind of defining our input, process, and output. Okay, what inputs do we need? That is height and weight. What should be processed? Okay, calculate the weight divided by height multiplied by height, and just output the BMI. And finally, just that is our pseudocode. Okay, send enter height in meters to display, receive height from real. Okay, that is real number from keyboard. Send enter weight in kgs to display, so again, and receive weight from keyboard, and that also has to be real. Set BMI to weight divided by height multiplied by height. So this will be calculated and it will be stored inside BMI, and send BMI to display. Okay, so that is just our final pseudocode if this question is asked in exam. Then the blueprint complete. Okay, final checklist. So you have just definition. Okay, algorithms are precise step-by-step methods to solve problems. The 5 rules: it has to be unambiguous, it has to just have the correct sequence, it should be finite, it should be effective, it should generate correct output every time, and it has to be efficient. Okay, it should just kind of work as fast as possible and using the least amount of resources of the computer. Okay, then the engine, that is input, processing, and output model. okay? And representation. Algorithms can be written as text, drawn as flowchart, or coded in pseudocodes. Okay, so written description, flowcharts, and pseudocodes. And for variables, always use descriptive identifiers to make your logic readable. Okay, so remember, a computer is a mindless machine. Your algorithm is the mind that guides it. Okay, so you have to just be very careful about it. And that's it. Wish you all the best. Good luck and goodbye. uh, Introduce us to your friends, to your classmates who want to just learn this concept. Okay, share our channel with them. Do not forget to like and subscribe. If any question, we would be more than happy to receive your questions in the comment section. Wish you all the best. Good luck and goodbye.